welcome back to our final video for section or chapter 5. This is on section 5.8. Let's revisit the first example we did today. Consider the sequence s sub k equals negative 4sk minus 1 minus 4sk minus 2. Let's look at what's going to happen and how we have to deal with a single root case. So unlike before where we had two distinct roots, here we're going to look at what happens with a single non-distinct root. So just like we did at the start of this section, let's go ahead and find the characteristic polynomial for this. So we have a is negative 4 and b is negative 4. So we have t squared plus 4t plus 4 equals 0. When we factor this, we get t plus 2 squared equals 0. So in other words, we found out that t can only ever equal negative 2. Now, unlike when we were dealing with the distinct roots, you'll notice that when we have single roots, we're dealing with also a linear combination, but it's a linear combination of the root with a multiple of itself, so a multiple combination in some way. So unlike the previous setup, we're going to still set up this equation, but now using a slightly different formula. So we're going to say here that s sub n is equal to c times negative 2 to the n plus d times n is just n in this case, right? So we leave that as is. So it's d times n times negative 2 to the n. If they've given us our initial values here, S0 and S1, let's go ahead and plug some stuff in. So S0 is 0, which equals c times this to the 0, which is 1, plus d times 0 plus this, which is 1. So this just goes away. So we know right off the bat that c is equal to 0. Now let's use what we know about S1 to finish solving where we have to go from here. So S1 equals negative 1. So that's c times negative 2 to the negative 1 plus d times negative 1 times negative 2 to the negative 1. So let's go ahead in here. We know that c is 0 right off the bat, so we don't even have to mess with this. If c is 0, 0 times anything is 0. So negative 1 equals negative d times negative 2 to the negative 1 is negative, so this is 2 negatives, makes this positive 1/2. So negative 1 equals d times 1/2, multiply by 2, multiply by 2, so we know that d is equal to negative 2. So to conclude this, s sub n equals c is 0, so this whole component disappears, times d is negative 2 times n times negative 2 to the n. Clean this up to conclude, Sn equals n times negative 2 to the n plus 1. So again, the entire process is exactly the same. We just use a different formula. We're not using the linear combination of the two roots. We're just using a formula which deals with the single root that we have